आंखें सपने देखती हैं और ताबीर लगता है नहीं आएगी। माँ हर इम्तिहान में बढ़ाती है जो हिम्मत।
कहा ना आएगी।
होंठों पे आ ठहरा है हर एक के जो सवाल। आ क्यों नहीं रही? भरोसा अपनी किस्मत पर, वो मेहनत की कमाई फिर चली गई जिंदगी के हसीन फ्लो में।
Do you face these problems in your daily life also?
Yes, I do face these problems, but I have an inverter in my home, so I'm not affected much from these problems.
So, being an engineer, future engineer, do you know about it? Do you know about the basic working of the inverter?
No, I have never thought of this before, but I would really like to know.
Good. So I will tell you about it.
Okay, Harsh. So basically, inverter has three major components. One is transformer, second is oscillator circuit, and third is the amplifier. So Harsh, now all our electrical devices in the house work on AC current, but we can store current only in the form of DC, and which is stored in the batteries, which are used in inverters. So what the inverter does mainly is to convert this DC current to AC current, which can be then supplied to all the electrical devices. So now in this flow chart basically shows the working of the inverter. Here there is a battery. Battery current goes from the battery to the oscillator section, where it converts it into the AC voltage. Then from AC voltage, it goes to the amplifier where the current intensity is increased. Then there is transformer which gives us a high voltage AC. Let's first talk about the transformer. Now, for understanding the transformer, we first need to understand the basic phenomena of electromagnetic induction.
Oh, great. I know about the electromagnetic induction. When the magnet is moved towards the coil, the pointer or the needle of galvanometer, which is basically a very sensitive center zeroed moving coil ammeter, will deflect away from its center position in one direction only. When the magnet stops moving and is held stationary with regard to the coil, the needle of the galvanometer returns back to zero as there is no physical movement of the magnetic field. Likewise, when magnet is moved away from the coil in other direction, the needle of the galvanometer deflects in the opposite direction with regards to the first indicating a change in polarity. Then, by moving the magnet back and forth towards the coil, the needle of galvanometer will deflect left or right, positive or negative, relative to the directional motion of the magnet. From the above experiment, we can easily conclude that a voltage is induced in a circuit whenever the relative motion exists between a conductor and a magnetic field, and that the magnitude of this voltage is always proportional to the rate of change of flux.
Now, as you know about the EMI, I can tell you about what a transformer is. Now, in a transformer, there is a primary coil in which we pass an AC source current. With fluctuating current in the coil, magnetic field also fluctuates. This magnetic flux can be associated to the secondary coil with the help of a ferromagnetic material. This alternating flux in the secondary coil will induce an alternating EMF in the secondary coil, producing an alternating current in that secondary coil. Now you must be thinking that what is the use of that transformer? Why are we using the transformer? So the useful thing of the transformer is that the voltage produced in the secondary coil is not necessarily the same as that applied to the primary coil. If the secondary coil is composed of a double winding, that has twice the number of revolutions with respect to the primary coil, the secondary voltage will be twice of the voltage applied to the primary coil. You can actually produce any voltage want varying the dimensions of the coils. Let's now see what does an oscillator contribute to the working of an inverter. It consists of only two NPN transistors T1 and T2. two capacitors C1 and C2 and four resistors R1, R4, organized in a symmetric fashion. The collectors of T1 and T2 are outputs which provide complement square wave signals. The values of the capacitors and resistors can vary, depend on the desired frequency, and their values do not have to be symmetric. So, how does this circuit work? To begin, when power is applied, theoretically both T1 and T2 should turn on since their base pins are connected through resistors R2 and R3 to VCC. However, due to small differences in the electric properties, one of them will turn on slightly earlier than the other. Without loss of generality, let's assume T2 turns on first. Therefore, T2's collector begins to conduct and chemically both T1 and T2 should turn on since their base pins are connected through resistors R2 and R3 to VCC. However, due to small differences in the electric properties, one of them will turn on slightly earlier than the other. Without loss of generality, let's assume T2 turns on first. Therefore, T2's collector begins to conduct and can be thought of as shorted to ground. Note that C2's right lead is connected to T2's collector, and since C2 is not charged yet, its left lead also has a voltage close to ground. This immediately shuts off T1, that is, T1 becomes an open circuit. Therefore, C1's left head is in floating status and its right lead is connected to T2's base due to forward voltage drop of transistors. This forward voltage drop is the same as a diode. Now, let us consider the stage 1. During this period, T2's collector output O2 remains low and C2 begins to charge through R3. Thus, the voltage on C2's left lead will rise. At the same time, C1 also charges through R1, so C1's left lead will quickly rise up to VCC and remains high. As C2 continues to charge, a critical moment will happen when its left lead rise up, at which moment transistor T1 will turn on and its conductor will conduct to ground. Note that since C1's left lead is connected to T1's collector, it will also drop to ground voltage. As C1 is fully charged, its right lead will suddenly drop to a negative charge minus VCC. This will shut off T2 firmly. Therefore, the circuit will suddenly transition to the following equivalent. Now comes the stage 2. During this period, output O1 will remain low and output O2 will quickly rise to VCC due to the charging of C2 through a small resistor R4. At the same time, C1 charges through R2. Now you can predict what's going to happen. As C1 continues to charge, the next critical moment happens when C1's right lead rises. At that point, T2 will conduct again while T1 shuts off. The same cycle will repeat. So by now, Harsh, you must have understood the basic working of the oscillator and must have also understood the basic working of the inverter.
Yes, Pulkit, but I have an inverter in my house which have UPS written on it, and I just can't understand why is there UPS written on every inverter.
One very common use for inverters is in emergency power supplies, also called uninterruptible power supply. If your household power fails on an outage, one might have a UPS as a backup. A typical UPS stores energy in electrical form using rechargeable batteries. When the power is flowing normally, the batteries are being charged by DC, which is produced from the AC power supply using a transformer and rectifier circuit. If the power fails, what you have at your disposal is charged up batteries that will produce direct current, but which we need to produce alternating current to power your home. So when the UPS is supplying energy, the battery pumps DC through an inverter to produce AC.
Oh, thanks Pulkit. Now I've at least understood the very basic of the working of an inverter